Yes, you're welcome, class, to this lecture. And this week, we want to start on something very interesting. And I would want to call upon all of you to pay attention as we go through this week, because from when we started, we have been working on using scripts when we're writing programs in MATLAB. Now we want to move to using graphical user interfaces. So it's quite going to be very interesting. I think this week will be very interesting because many of you are going to appreciate that the codes that you've been writing, that you can be able to create a graphical part that can be able to incorporate your functions, or whatever you have been writing before, and you can appreciate why you need to use MATLAB. As I said, we're going to look at graphical user interfaces this week, and I would want us to get started. Why do we use a graphical user interface in MATLAB? This is a fundamental question that we need to ask ourselves. Do we really need to use a graphical user interface? There's just one major reason for us to use graphical user interfaces, or what we famously call GUI, because it makes things a little easier for the end users. If you wanted to develop an application that somebody else would want to use, or you want to share it with your friends, you want to share it with some person, it will be good that you make that application as much easier as possible. So most times, people who have not developed the applications, they literally don't understand the nitty-gritties of your program or your application. So it is important for always endeavor to make sure that it is as easy as possible for the end users to use, or somebody who want to share your application with to use your program. It's always very difficult to let users execute a program through the command window and the command lines. So it is always very, very hard. That's why we need to have a graphical user interface that somebody can just be able to be guided on what to do. Users looking for easy apps to use. That's another reason why we need graphical user interfaces. Users look for easy apps to use. If your application is full of commands and write this, write that, I would say that not many people would want to use such an app. So you would want your users to find it easy to use your application. So the graphical user interfaces make such programs very user-friendly and very attractive to users for them to be able to access them and use them. Very, very important. Why we always need to think about writing programs in graphical user interface. Okay, how are the ways how we can build these apps, or apps that have graphical user interfaces in MATLAB? There are a number of ways we can be able to build these apps. One of them is using a command called App Designer, and we shall be looking at much more using App Designer this week. But App Designer had a legacy command, a legacy functionality called guide, which literally is the old version of App Designer. App Designer is the newer version, has more functionalities, easy to use, much more than guide. So uh, literally work the same. And you can also use MATLAB functions to create apps. You can just program apps from scratch. And that little going to take you some more time for you to do that. Okay, so each of these approaches offer a different workflow and a slightly different set of functionalities. So if you're going to use App Designer, it will offer you a different workflow from using Guide or MATLAB functions if you're going to create these applications. The best choice for you depends on your project requirements and how you prefer to work. So you can choose to use App Designer, you can choose to use Guide, or you just create functions in MATLAB, just program from scratch. So it depends on which literally your work, how you prefer to work, and what are the requirements of your project that you're working on to determine which way for you to build your apps. When you're using an app designer, um, it is a rich drag and drop environment that has been introduced in MATLAB version of 2016A. So since 2016, MATLAB has a newer version of Guide, which we call App Designer. So it is a drag and drop, and we shall be seeing that as we demonstrate a little later in this lecture. So it is the recommended environment for building most apps because it is easy, you just drag and drop. So we always advise that you use App Designer because it is the most recommended. Okay, it's the recommended environment for you to build most apps. It includes a fully integrated version of MATLAB editor, and the layout and the code views are tightly linked together. That's what is beautiful. When you go back to the code view and come back to the layout view, you find it's easy to link for you to your program. So the changes that you make in one view immediately affect the other view. So if you're changing in the layout view, it will also be affected in the code view, as we shall also see little later. A larger set of interactive controls is also available, including gauges, including lamps, knobs, and switches. These are very good controls that can be able to be used to program some apps. So most graphic functionalities are also supported. So it's always advisable or recommended for you to use App Designer when you're developing your applications. Okay, so it's going to be a little fun if turning our code into a graphic user interface. These are some of the tools that App Designer provides. Have a number of components. You can see a lot of them. We have the components here uh, outlined here, and we'll be looking at most of all these and how do we use them. And these are some of them, but this is the design view. You can see that this is in the design view. You can just put these controls in the design view, and this is the code view. So you can also see in the code view. But in the design view, every time you click on any of the controls, their details are displayed here, and the component will be also shown here in the component browser, where all your components that you're working with are displayed. And then, of course, you can also change some properties on each component that you're working on, and we'll be looking at that uh, shortly. Okay, so the second way for you to build apps is by using Guide. Guide is also a drop and drop environment for laying out user interfaces. Okay, so you code the interactive behavior of your app separately. You have a drag and drop, and then you code the interactive aspect, the interactive behavior separately in MATLAB editor. So apps created with Guide are compatible with almost all other releases, and they support all the graphic functionalities in MATLAB. So you can choose to use Guide, but one fundamental difference is that when you're coding your application, the interactive behavior of your application is separated from the editor or from the interfaces that you're working on or that you're creating. That means you're going to have your interfaces designed separately, then code them in an editor separately. Okay, so that's something that you need also to literally understand and put in consideration. Okay, so you use the guide command at the command window or the command prompt. You just type the command guide and to be able to provide for you that interface, which gives you a quick guide uh, to working with guide. So it will give you or to help you to create new graphical user interfaces and having your default a blank GUI, which you can be able to select the options from, then you can be able to look at the existing applications as you desire. So it is important for you to understand that even as if you went back a little, if you're using App Designer, still for you to come to this window, you have to run a command App Designer. We shall be demonstrating that. Okay, so as here at guide, we're saying that at the command window, um, you type guide and then it will give you such a screen. You can also now add objects, but you just drag and drop. You can see the objects are here or the components. So you just drag and drop, and that's how they'll be appear, and you can be able to edit each of the component in the panel here. Then you can be able to get all the details. So this is a guide window. So when you drag and drop components from the menu and the icons, you'll be able to create the graphical user interface. What about if you wanted to use the MATLAB function? When you want to use the MATLAB functions to create apps programmatically, you can also code the layout and the behavior of your app entirely using MATLAB functions. Okay, so it is you can just code from scratch and just use functions. This function does that, this function does that. But I would want to warn you that you need to have good programming ability for you to use the MATLAB functions because you're going to be creating these functions yourself of what you want exactly to do and which part will want to do what exactly. So in this approach, you create a traditional figure and place interactive components in that figure programmatically. These apps support the same type of graphics and interactive components that Guide supports, as well as tabbed panels. So you can be able to do that using MATLAB functions that you create or that are inbuilt, because they are also inbuilt functions. Okay, can look at such a sample of the function. So this an app that uh, provides this. So that's the code that has been developed, which is .m. So MATLAB functions are .m functions. They can be able now to call this function and be able to provide such an output. So MATLAB graphical user interfaces, as you're working with them, consist of two files. You have what we call an M file, which is a .m, and the figure file, which is a .fig. So the M file has all of the code that controls the graphical user interface, or the GUI, and the figure file has all the graphical objects, positions, default values, and links in all together. So we have two files. The GUI consists of two files. So one is an M file that has the code, and then the figure file, which provides the .fig. Okay. So this can be an example of a graphic user interface where we have the edit boxes. These ones are edit boxes. We're looking at that. And then we can use radio buttons. Okay. These are radio buttons. That means choose any of these. You can't use both. This is a push button. Okay. When you push or you click on it, something should happen. So it's a button, which is a push button. You can use those to create also functions in that aspect. These are axes. This is a panel. Okay, you have put all this on the panel. We have pop-up. You can just have a drop-down menu, a pop-up menu down here. Then also you can be able to have a static text. You can just create when the text is fixed, or you can have a scope adjustment here. So this can be a nature or a look of a program that you have designed that could be able to look something like that. So in your when you're doing your project, would be expected to develop some beautiful applications that can be able to do or solve certain problems. Okay. So how do we handle graphics? Handle graphics are low-level graphic functions that control characteristics that are generated by MATLAB. They allow the programmer to have precise control of the same appearance of plots and graphics. Each component has a list of properties that define what it looks like and how it behaves. When you're plotting something, you have to get the figure window, then go to view, property inspector, and then more properties are checked out. And then the set and get commands are also worked on. These are the primary commands that you use to set and get information about graphic objects. They update the graphical object and immediately uh, they update the graphical object immediately. The syntax is you use the keyword set and then you put the object handle here, then you have the property name and then the property value. The syntax for using get is you have like the property value get, you have the handle, then the property get. So you use get to get the object handle and the property value. That's when we want to set to get setters and getters. So when you're creating a GUI, step one, you create a graphical component. If you're using guide, manually configure each component. Step two, the program components. The guide will generate the primary file. You must add to this file and all of the actions your component will take. And then step three, interface. Interface with your analysis tool. So there are three steps. You're using guide, creating graphical components. Okay. Step one, create a graphical component using guide. Manually configure each component. And then step two, program your components. Here, guide will generate the primary file. You must add to this file all of the actions your components will take. Then step three, interface with your analysis tools. The components and their names are visible. To add a component to the workspace, you select it and drop it there where you want it to be. The size of the component can be also changed by dragging the edges or changing the position. That can be done by double-clicking and dragging it. So let's look at each of the components before using them. We have what we call the push button. It is a function to call the callback function for the execution of different programs. So we use the push button to call functions that are called callbacks. We shall be looking at that programmatically shortly and test out something shortly. Okay, so it is important to understand the components. Component number one is push button. Component number two is the slider. It is similar, to a scroll bar with a numerical value. So the callback function is called and executed when the user changes the pad position of the slider. So the pad position can be changed by dragging the pad to the required position and clicking the forward or the backward arrow. In that way, you'll be sliding or moving backward and forward. Component number three is the radio button. It has on and off states. That means it is either on or off. You cannot select more than one radio button. So its state can be changed by clicking on it. And when the button contains a solid circle within the whole circle, then it is on. But when the whole circle is empty, it is off. They are grouped and only one can be on at that time or at a time. We have checkboxes. These have on and off state as well. The state is represented by a tick inside the box. They are grouped and several checkboxes can be on the same time. We have the edit text is for getting strings as an input from the user. The input can then be modified to numbers using functions like str2 num or this str2 double functions. Then we have also static text. This is to add labels that remain unchanged on the graphical user interface and have no callbacks. If you're using static text, it's going not to do anything. Okay, it's just going to be static text and have no functions or function callbacks. We have pop-up menus. A pop-up menu is for listing selections. You click on it to view the selection, and then callback function is executed depending on the selection. We have the list box. It shows a list of selections just like this pop-up menu. In this list box, all the selections are visible throughout, unlike the pop-up menu where only the current selection is visible. But also you have the toggle button. It functions similarly to the radio button, but different appearance in the graphical user interface. It is the appearance that makes that difference, but the functionality is actually the same. We have a table. It is used to add a spreadsheet to graphical user interface. If you have data in a spreadsheet, you can be able to load that data into a table. Then you can, in case of modification in the input, the callback can be executed then. We have axes. These are for the addition of images, charts, and plots to the graphical user interface. They have no callback function. And then we have panels. These are used to group several components and names according to the functionality. It doesn't have a callback function. So you can group radio buttons together. You can group maybe edit text together. So whenever you're grouping them, you group them using a panel. And also they help you to arrange well your figure that you're developing or your GUI so that it looks neat and appealing to the user. Then we have button group. It is just like the panel, but used to group radio buttons. When we group the radio buttons here, similar to a panel, we first add the radio button before adding, so with the radio group before adding the radio panel. So you have to first put, similar to a panel, you first put a panel, then you'll be able to add these components onto the panel. That's the same way when you're using a button group. You first create a button group, then you'll be able to add these button or radio buttons or other buttons on the panel. Okay, after doing that, then you are now ready to activate your graphical user interface. You just click on the green red arrow to activate, which you have been running before. Okay, when we are writing scripts, so that green arrow, when you run it, to be able to activate and then save the graphic user interface under some name. Maybe you're calling it first GUI, that's okay. But you have to note that names must follow the same rules as naming variables in MATLAB. You need to go back and understand that. Okay, so an M file will automatically open with the same name, and then the GUI, which currently does the most almost nothing at this point, will also launch. Then an M file has callback functions where code can be added to control what the various objects like push buttons, like drop-down menus, like plots, extra will do. So any executable MATLAB code can be placed within these functions. Okay, be placed within these functions. So it's very important for you to understand that. Okay, then we can look at a demonstration. Can look at a demonstration now. As we look at a demo, you need to also now open your MATLAB, because we are going to look at an example. Um, so I'll just end this and then start afresh to do the demonstration. Thank you for listening.